Good evening, guys. So I'm so sorry that I can't get my. I'm currently downloading the. I have a tablet, but I just got a new PC and the driver is not on there, so it's not connecting. So even though the light is on, I can't write anything with my tablet. Okay, so it's just the way it is. I think a few people are waiting, and mechanics tend to be the one that I don't know, probably the most difficult to go through without some form of writing. But I'll try my best. We'll just see how it goes. It's just technical issues when you have a new PC and then it does things like this. Okay, so we'll just go, so I printed out this 2017 mechanics paper. I will just go through that with you guys, and we will, do our best without without the tablet. It's just how it is. Okay, so it's I'll just use my cursor, so you can just follow my cursor around. Oh wait, did something disconnect? Is that my pen mark? No, it's not my pen mark. That just I'll just use my mouse pad. It is this will just do for now. Okay. What does air resistance? So the speaker has a question, so I just use a mouse to do this. Okay, so I probably won't do much writing today because I'm limited by the thing I have. Okay, so I'll just answer you guys' questions about mechanics first, and then I'll just quickly speed run this exam paper without too much writing. Okay, so apologies for that, but it's just unfortunate. And I'm staring at 2 hours of download time for 100 megabytes of tablet driver. I don't know why that is, when I can download like a 20 gigabytes game in 5 minutes, but I'm downloading 100 megabytes in an hour. So don't know what's going on there. But let's have a look at this. So I have the exam question prior to this. What does air resistance to do with the object when it's moving down? Why does it not have a constant speed? What does the friction force do? So you need to give me more context. Like what's happening to the object. So if something's free falling down, let's say one of the most popular questions that you tend to get asked is the like a skydiver. So a skydiver that jumps down. So that skydiver, I'm so used to grabbing my pen now, so I'm just gonna have to do it like this. So if you got a skydiver, and then you got gravity, weight to going down there, you got friction going up this way. So if you look at free falling, why it doesn't have a constant speed. Okay, so at the beginning, so I do have a recording on this, I'm pretty sure. So what happens when you just, like say this person jumped out of the airplane, right? The moment he jumps or she jumps out of the airplane, you have a lot of gravity or weight force going down, and then there's very little air resistance, so that's why the person will accelerate at the beginning. Okay, so he will accelerate at the beginning, but over time what's going to happen is that the air resistance will start to increase, which will start to balance out the so you can think about the friction, but this is air resistance. Oh man, it's so annoying without a pen. So the forces kind of balance each other out, and that's why the person would have reached would have reached their terminal velocity, so they can't go any faster. Okay, so and then when they open up the parachute, you have increased the air resistance and friction, so that person slows down, and but then after a while that the gravity and the added friction force start to cancel each other out, so the net force is again balanced, so that person will slowly just make their way down the thing. Hello Nate. So Neil asked, can you explain why kinetic energy is not equal to the gravitational potential energy, how the loss can affect the speed or something? Okay, so Neil, that question, I think there might be a question in here. May not be, maybe. I haven't seen this exam paper. Nope, this is pressure. This is work. I'm not seeing it. Maybe this exam paper doesn't have it. Okay, so in your case, Neon, you're talking about kinetic energy and gravitational potential energy. Okay, so the most common example that I ask everyone to do, you know, because everyone has a pen, all right, you're writing notes down, you have a pen. If you're holding a pen up, that pen has gravitational potential energy. So if you let go of that pen will start to free fall and, you know, start to have a kinetic energy because it's falling down towards the ground. It's going to lose its gravitational potential energy, and that's going to convert to kinetic energy. Okay, so if you have a pen right now, you know, just hold it up, you know, just, you know, a couple meters high, and then just let go. And if you let go, you're going to see the pen falling down, and it's going to make a sound when it drops on the floor. So when you get what we call this type of question, and when you see this terminology called assume energy conservation, or assume no energy is lost, and that is when you need to make the assumption that the EP is all converted to EK. Okay, so that is what we assume. So that is when you can calculate the theoretical maximum speed. So you pretty much just have, actually I can just type, you know. So in this case, I'm just going to type it here. Alright, so actually let me just use select. So what that means, you are assuming that EP equals to EQ equals to EK, and then this is where you can, if you know the mass, if you know the gravity, if you know the height, you can calculate EP, and then you can use that number to calculate the maximum theoretical speed. However, not all of the EP is converted to EK, okay, because of so, you know, we can do the stick-to calculation, but the theoretical maximum speed cannot be reached, and that is because due to some of the energy is lost due to friction and heat, and you lose that away. Okay, so you will not, you know, that loss of energy, that means you can't reach that maximum speed. All right. So we ask, hi, so just a quick question. When putting area into pressure, is always in meters squared? Okay, so area, so pressure equals force over area. Now force is measured in newtons, okay, and then your area is measured in meter squared. Okay, so you have to, now in some questions they may go the length is 2 centimeter, height, width is 1 centimeter. So what you need to do is that you need to convert the 2 centimeter to meters, you need to convert the 1 centimeter to meter, and then you will need to use those meter values to calculate the area. Okay, so you have to be meter squared, otherwise that's wrong. What paper are doing? This is mechanics. Okay, so can you give extra help to my friend Simran is in the stream right now? Well, Simran need to ask me a question. Okay, so could you explain free body diagram, especially if an object is free falling? I just did that, Marty, like literally just now with this little dude that I drew on here. Okay, so if you actually, because I've done this before, I've teach this every single year. Okay, so I'm just gonna quickly go through this again. If a person's free falling, if a person jumps out of a perfectly fine airplane and skydives, you pay a lot of money to do that. So the moment he jumps out of the plane, that person will start to accelerate. Why? Because the force of gravity, actually I can type this down. So I'm not going to draw a diagram because my pen's not working. So, you know, jump out of the plane, so that's when force of weight or gravity is greater than the force of air resistance. Okay, and that means this person will start to accelerate. So you just need to draw, and you just need to draw accelerate. Yeah, I can't spell. On an E. Yeah. So you just need to make sure that your downward force is bigger than the upwards force, and then after, like, say a minute or so, you reach terminal velocities. That means you can't go velocity, you can't go anything higher, you can't go any faster, and that's because your forward rate of your force of weight is equaling to the force of resistance. Okay, and then if you pull the parachute, pull the chute, and what's going to happen is that you will slow down. Why do you slow down? Because your friction force is now, or the resistance force, the air resistance force, whatever you want to call it, is going to be greater than your weight force. So you will have the net force is now, net force is upwards. So that's why you slow down. Okay, and then you will just flow downwards. All right, that's what we can kind of talk about here. All right, so with mechanics, because of the limitation, that keyboard is a bit loud. Yeah, it's my awesome Mechanic keyboard. Sorry. Yeah, it's very satisfying when you play games and then you got a very loud keyboard. Sorry, just my personal preference. All right, so you got so one thing that you guys need to do is to make sure that you know how to use this formula. Okay, I marked physics last year, I marked mechanics last year. Okay, and I can tell you from the experience that I had last year is that if you just write down the correct formula in your problem, like say when you get a question, like say for example this, not this one, let's say not this one, let's just look at any question. There we go. Like say for example this, use a Waka as an example, include a calculation. Okay, so if you include a calculation and then you put the correct formula in your working, like even if you don't solve the question but you have solved, you have given the right equation, you get one achieved, and you need like 9 points to pass. So you need to know what these equations stands for. Okay, so you need to know what the units are, you need to know what they stand for, and this is like a half an hour job. Okay, if you want to pass physics, you need to really just understand one, if you know the very basics, and some people complain to me like, oh sir, this is just math, I suck at math, I can't do this. Then for at least just understand what the question is asking you to do and put down the right equation. And then if you can do that, might as well do a little bit more. Substitute, find the number in the paragraph, and then just substitute that in, and then that's how you get like you achieve some merits. Okay, there's very little writing, and trust me, most of the 11 that I taught in the past, they always say, oh, mechanics is the easiest one, and when they go to physics in level 2 and they get completely destroyed because it's the level of the physics that we do in year 11 is very little. Okay, and how many marks do you need to get excellence? No, Marty, 19 won't get you excellence, but 21 secures your guarantees and excellence. 80% of the time gives you excellence. 19, maybe 5% of the time gets you excellence. Okay, because it depends on the cohort. It depends on the cohort, and trust me, we have not, for all the papers that I've marked for the past 5-6 years, we have not given E's for people getting 19. Okay, unless it is a really difficult paper and not a lot of people are getting excellence, that's when we lower it down to 19. But 20 is normally, what we go for. 21 guarantees excellence. It doesn't matter how easy or how hard the paper is. If you get 21, it's excellence, non-negotiable. Okay, but I think the questions are quieting down a little bit, so we just want to go through some of the questions here. All right, so when you get a question like this, Sam and Danny, you just need to understand, the first thing you need to look at is the axes. Okay, so this is a speed time graph, and when you get a speed time graph, so when you see motions like this is when you are accelerating because your speed is increasing. This is constant speed, this is increase in speed, this is constant speed, increase in speed. Okay, so you need to be able to understand that. And once you got that, you need to understand here is that the gradient, why is that so small? I'm just gonna do it like this. So the gradient is in the speed time graph is acceleration, is the rate of acceleration. Okay, so you need to know the units ms -2. Okay, sorry, you can do the superscript. Can't be bothered doing here. Okay, so that's what the gradient does. So if we use the information in the graph to compare the speed and acceleration of Danny and Sam in the first 60 seconds, so there's no calculation involved. You just need to compare them. So in this case, you just need to look at the graph. Let's look at Danny. So Danny's a blue line. So you can see here, this graph is not as steep. So you can say in the first 60 seconds, which is up to this line here, so you can say Danny has a, you can clearly see this line is not as steep, so the gradient is less. That means Danny has a lower acceleration. And then you can see Danny has a lower constant speed of 7 meters per second. Whereas Sam is a bit of a speed demon here, so Sam is going at, this horse is going pretty fast. It's accelerating faster because there's a steeper graph, a steeper line. That means there's a higher gradient. That means there's higher acceleration, and this horse also has a higher constant speed of 8 meters per second. Okay, so that's that. Done. And then Sam's horse accelerates for the first 10 seconds of the race and covers a distance of 40 meters. Sam and his horse have a total mass. Use acceleration to calculate work. So this is where you need to look at the question and go, all right, work. How do I do work? So work is, not sure I can type here. So work is force times distance. Okay, so you need to be able to find, again, this equation's on there. Just get into the habit. When you see calculate work, just chuck the equation down. Do you not want a free achieved? It's really, we're literally giving you free marks. Okay, so you just need to take those opportunities and run away with the credits. Okay, all right, so let me just finish this one here. So work is force times distance. So what you need to find out is work. So what work are they doing? So it's the horse and them running. Oops. So we're looking at the work, the force. The force in this case is the weight force. So which is just 308 times 10, which is 3080. Oh, look at that, that's forming automatically. So 3080 newtons. Okay, so if you know the kgs, you know the weight force. And then how much distance did they do? Covered 40 meters. 40 meters, so it's just 3080 times 40 equals this much joules of energy. Okay, that is really use acceleration to calculate the work. So force times how much work they done, force times distance. Okay, well, actually I've done this incorrectly. Looking at, this is where you use the other equation. Sorry, this is force equals ma, because now that's actually a good point. When you do force equals mg, this is when you are like lifting things, when you're dropping things, especially lifting things. Okay, when you're lifting things to a certain altitude, you are overcoming the weight force. Okay, so you are overcoming, so my keyboard is probably bothering you, overcoming the weight force. Okay, but in this case, we can see the horse is running. So the horse is running, so we use F equals ma. So the ma, this means that the horse is running, and so you can't, it's more, we're not looking at, we are interested in the acceleration. Okay, so we're interested in the running part. So how do we figure out ma? So it's where it says 308 times 10, not 10, where the hell is it? Horse accelerate for the first 10 seconds. I actually need to go to the graph. So where's the graph? First 10 seconds. Oh god, where's my rubber? So who are we doing? To calculate the work that Sam and the horse. So the Sam for the first 10 seconds. First 10 seconds, so it's from 8, so it's literally rise over run. Let's do rise over run. So it's 8 divided by 10. So it's 8 divided by 10, rise over run. So it's 0.8. Okay, so the acceleration is this without writing. This whole no pen thing is really throwing me off. So it's 0.8, and that will equal to this many newtons, and then you will just simply do, my stupid driver thing is not even downloading right now, so it's 246.4 times 40 meters, and that will give you this many joules. Okay, yep. So just make sure, if when they say calculate work, you need to look at the question. So don't make the mistake either. So if they're talking about lifting things up, you're looking at the weight force. If they're looking at something that's running, that's in motion, that's accelerating, you look at the acceleration. So you use F equals ma in this case. And now if I talk about if I'm lifting this horse up with a crane, and then how much work has a crane done, then you look at the weight force. Okay. So Nia had a question. So could you explain what we have to write in the if the equation asks you to describe the impressions made by the pressure of an object, how the area would affect it? Could you explain what we have to write? Okay, so that's pressure over. So that's P equals F divided by A. So the bigger the weight force, the more the pressure. The bigger the area, the less the pressure. So that's, you need to look at the question specifically. Okay, how do you explain when two objects have the same pressure but have different force and area? Okay, yeah. So that's that question. The adult, the child and adult with the sand. I'm pretty sure you are referring to the 2021 exam paper or the 2020 exam paper. I'm pretty sure it's 2021 because that question rings a bell because I would have read 700, 800 of those exam scripts. Okay, so in that case, if you think 2019, yeah, I would have seen that. I've done that on my YouTube channel if you want a detailed explanation. So think about this: if a big person like an adult is standing on sand, a child is standing on the sand, but then they exert the same amount of pressure, because how does that work? Well, pressure, let's go down to the very bottom, let's find a bit of space here. So pressure equals force divided by area. Okay, so if your adult, in this case of your adult, has a large force because that person weighs more, and also has a large area because he has large feet. If you look at the child, has small force because the child weighs less, and also the child has small feet, he has small area. So let's give you this answer numerically, because I again don't I'm trying to show you this to comprehend this. If I use, like, say 100 divided by 10, can you see this will equal to 10, right? Can you see if I, let's just say, if I use a smaller number divided by a smaller number, can you see this also equals to 10? Okay, so this is, I don't know, but the most of the 11s I come across are not great mathematicians. You just need to understand that pressure is a ratio between force, and is how much force is distributed over a certain area. So you can have, so you need to look at the relationship of the area and the force. So in this case, an adult has larger feet, but that person also has larger area, so larger weight force. So that weight force is distributed over a larger area. Therefore, it has the same amount of pressure compared to a smaller person distributing their weight over a smaller area. Okay, so that's why it's a, yeah. Yep, okay, your calculator will do the job. To do well in mechanics, you just need to make sure you put in the correct numbers into the questions. Okay, so we've done that. So I mean, you kind of again, because of the limitation that I'm going through today, I can't explain everything that I would like to as well as I could be doing, because I like to jot things down. But I'll just go through the ideas. So you're probably on the pause and watch a VOD. When you watch a VOD, just listen to what I've said, because I'm not being able to write it down because my keyboards are also very loud. Yeah. Rohit asks, how do you explain net force and link to the direction? Well, just remember, if the forces don't, the simple analogy. Hopefully, I don't know, everyone would have heard of Squid Game. The TV show. You would have done tug of war some time in your life. big rope and a group of people pulling each other. So how does that work? Very simple. If you got net force means if you got people pulling to the right is greater than the people pulling to the left, then the rope will accelerate to the right. Okay, so net force is all about cancellation. So if you got 10 newtons to the right, 2 newtons to the left, they'll cancel, but I have 8 more newtons to the right left over, so my object will accelerate to the right hand side. It's as simple as that, and then when you have a net force, okay, like say for example, look for something on your table right now, like your phone, your laptop, your calculator, your book. If you push that object, the object will start to accelerate. And why is that? Because you're giving it a force. And if you let go, the object will stop to accelerate. Why is that? Because there's no more forces acting on it other than the support and gravity. Okay, so you need to understand that when anything is accelerating, it's because the net force is not zero. That means there is a net force going in the direction of that. That's why it's causing it to accelerate. And if the forces cancel each other out perfectly, that means the object is either stationary. Like say right now, if you look in front of you, if you staring at your computer screen or looking at on your phone or looking at your iPad or whatnot, that screen hopefully is not moving. That's because the forces acting on that particular object is the same. So they cancel each other out, and therefore that thing doesn't move. Okay, so if you imagine if that table that's holding your computer screen suddenly disappears, your screen will drop down to the floor because the forces are no longer canceling each other out. Okay. All right, let's have a look at this one. Explain the effect of work and power. No more questions here. Explain the effect on work and power if a new heavier jockey was on Sam's horse, which had the same speed and acceleration over the race. Okay, so this is where you need to understand the equation here. This is where you need to understand the equation. Explain the effect on work and power. Power is work divided by time. If a heavier jockey is on Sam's horse, so which had the same speed and acceleration over the race. So you need to think about this. So what has increased is that the mass has increased. Okay, because the jockey is heavier, so that means a combined mass is greater. That means the force, the force is going to be greater, isn't it? Because it just makes sense, right? Because acceleration is the same, this acceleration is the same, but your mass is greater, therefore your acceleration will be, your force will be greater because your mass is increased. And if your force increases, you're running the same. If you're running the same amount of same length, then your work would have increased. Okay. Now, so that's how it works. Now, if the jockey somehow, if the new combination of the horse and the new jockey finish the race in the same amount of time compared to what they had before. So remember, power is work divided by time. Okay, so if they finish the race in the same amount of time, so this T number is the same, but work has gone up, so that means you got a bigger number divided by the same number. That means your power would have increased. Okay, so yeah, it's you can have a look at the model answers, but it's just need to understand. Like say for example, right? I always love using this example. Because across our school there's a shopping mall, and I always love using this example because every time I go to their library I see this every time, because there's a little ramp outside this shopping mall, right? So you can imagine this. If I want to push a bike, I have a bike here, and if I want to push this bike up here, let's say this is 3 meters, this ramp has a height of 1 meter, let's just say, if I push this bike along the ramp to the top, this is my destination, which is right here, would it be easier? How much work would you do? Okay, so to calculate the work, in this case, can you see that the amount of work to get the bike to that position is that it's the same as the gravitational potential energy that this particular bike is going to gain after I get it to that height. So it's amount of mass times the amount of gravity times the amount of height, and then that will give you the amount of what do you call it, the amount of gravitational potential energy. So can you see it makes no difference how I get the bike up there? Okay, so you can see I can push the bike up there, and when I get to the same height, it will have a certain amount of gravitational potential energy. So if I can't be bothered to push the bike up 3 meters, I can lift up the bike by 1 meter. So I can just pick it up, chuck it at the top of the ramp. Can you see at the top of the ramp, your bike will still have the same amount of gravitational potential energy? So the amount of work that you do in both scenarios is the same. Because you have reached what you've done, you got the bike to the same position. I hope it makes sense, but you may go, but it feels easy. It is easier to push the bike up there. I'm not doing as much. I feel like I'm not doing as much work. And the reason for that, can you see the distance here? Can you see? Because you're using less force. You're using less force. That's why it feels easier, because you're doing the same amount of work in a longer distance, so you are investing in less force. That's why it kind of feels easier. But the amount of work is the same. All right. But then if you look at power, I like using an analogy on power here. Like, say, if you can imagine your class, 25 people. If I go, all right, I want to find the most powerful person. I want to find the most powerful person in the class. So what I'll do, all right, 20 push-ups right now, everyone go. And I'll just look at who does the 20 press-ups in the shortest amount of time, and then that person will be the most powerful. And you may go, all right, that seems fair. But if you look at that in the scientific aspect, if you substitute that into the equation that we look at, which is power equals work divided by time. So can you see that everyone's doing the same amount of work? It's all the 20 press-ups. Okay, but then the person that did this in the least amount of time would have got the most amount of power. Okay, so that's working power for you. Which one would first? I don't know. I've talked about this with my level 2s and level 3s yesterday. Can't remember what year. And someone asked me which one I should start. Like, if I was sitting exam, which one I should do first. I personally recommend. You will know everyone's different. Okay, everyone's different. But I would always recommend do the one that you feel the most confident. So it doesn't matter if it's mechanics, essence and basis, or genetics. Do the one that you are most confident with. Because we human beings are very, a lot of your performance in the exams are dependent on your confidence level and your stress level. Okay, so you may have performed, like, say, 80% of your ability, or sometimes I've seen some people, only perform to 30% of their ability because they get stressed. When you start doing your most confident paper that you know that you're gonna do well in, and then you open the paper and you're gonna be like, yeah, I can do this. Yeah, no surprise questions. I got this. And your confidence level just, goes over the roof. You feel that off the roof. You're like, I can do this. And then later on, when you get your not so confident paper, you might even want to give it a go. Okay, like vice versa. If you pick up a paper that you're not so confident about, and then you start reading about it, and then you can start to see questions that you're like, what the heck is this? And then that's going to sit in the back of your mind, and then that might influence your ability to perform. Because even though later on when you pick up the paper that you're normally quite good at, those questions that you couldn't do in your less confident paper will be constantly coming back and say, you can't do this question, there's a question you can't do in genetics, there's a question you can't do in mechanics, and that will just keep haunting you for the next 2 hours, and then you just can't get it out of your head. So start with the most confident one. Okay, that's what I always personally recommend. You will not run out of time. Okay, if you're running out of time in your science exam, you're writing way too much unnecessary stuff. Okay, so that's my personal advice. So let's have a look at this one. So what's this doing here? Speed time graph is repeated below. So Sam and his horse traveled 710 meters. How much further had they traveled compared to Danny and her horse at this stage of race? So this is, you can look at the question here. After 90 seconds, which is here, this point here. When you look at this is when you see traveling distance, how much further, how much distance they traveled. This is a typical area under the graph question. So when you do distance in a speed time graph, you calculate the area under the graph. Okay. So we need to look at, in this case, Danny, which is the blue line. So you need to cut it. You need to cut this here, 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 and you need to calculate the area. You know, calculate those 4 areas, add that up, and then minus 700, and compare that to the 710. Okay, so in this case, Sam and his horse would have run more. So you would have figured out the number, you know, with us, and then add it up, use 710 minus that, and that will be your answer. And this is an excellent question. So with the speed time graph, the distance part is always an excellent question. You find the area under the graph. So what you need to be able to do is understand that each one of these, so let's say for this triangle will be half times base, which is 20 times 7, which is this triangle. And then this triangle here will be, you starting at 20, you finish at 40, so your base is 60, sorry, your base is your base is 40. Half times, I'm writing with my mouse, that's why it's even worse than what a handwriting normally is. Half times 40 times 7. Okay, so this is, you need to look at, you just basic math, basic geometry. Okay, so if you're like, all right, I'm not an excellent student, so I don't want to do this. Change that mindset. If you can, an excellence question normally has like 4 to 5 achieve opportunities. If you just leave it blank, you're throwing away easy achieve ticks. Even if you can show the working, if you can attempt to show some understanding, like you can attempt to get one of those right, you will get a achieve tick. You need 9 to guarantee a pass. 4 credits. Don't leave your questions blank. All right. So next one, what's the difference between mass and weight? Mass is the amount of matter in an object, whereas weight is the amount of force that is acting on the matter due to gravity. So mass will always be the same. So if this canoe weighs 9.9 kilograms, this canoe, if that canoe made its way into space, into Mars, into the sun, it will also always have 9.9 kilograms. Okay, but the weight will change because the amount of gravity will change, and then, you know, that will change. All right, so let's look at this. This is pressure, nice and easy. So we got two area calculations that we need to do. So you simply just need to remember to calculate pressure is width times length. So you got this measurements here. So just, they're already giving it to you in meters. So you just need to make sure you multiply them together to get the area. Use the force, use the weight force that you calculated here, divided by the pressure, divided by the area that we calculated here to give you the pressure. And something that you need to be able to do, guys, you need to do some past year papers to get the hang of it, especially in physics, is that most of the time the answer that you got from a previous question is most likely going to be recycled in the next question. So if you feel like you're missing numbers, you're like, I don't have enough numbers, I don't have enough clues, I don't have enough evidence, then you need to look at some of the questions that you've done previously in the same large question, because that's what they always do in physics. In mechanics anyway, they want you to reuse some of the numbers that you calculated before. And then this is where you might go, all right, so what if I stuffed it up in the first one? You know, if I got this first calculation calculated incorrectly, if you were supposed to reuse that number, and then if you got it wrong in the first time, but then if you in this next calculation you decided to continuously use that number, you will not be punished. That's what we call carried error, because you already made the mistake once. We can't mark you down again because that just seems stupid. Like you're being punished for the same mistake over and over again, which is just not fair. So if you can, this is where you need for this paper, you actually need to do the achieve part first to get some of the answers later. Whereas for genetics and acids and bases, you can actually just, I don't recommend this, but you can technically just go straight for the excellence questions and get E's that way. But for physics, you actually need to take your time, start with the achieved, because you need to use some of those numbers later on. Okay, so this is a good example. So next one, so here explains why the waka sinks further into when the pedal sits in it. Because you remember pressure equals force divided by area. So one thing you need to understand, the area is the same. So the person sits in the boat, doesn't change the area of the boat. So the area stays the same. And what happened to your pressure is that your pressure, this force, this number has increased. So this number stays the same. So can you see that the amount of pressure would increase and therefore you sink further? Done. Excellent. And then you can show calculations. So what you need to do, so you need to remember the mass is 67 kilograms here. The mass is 9.90 kilograms here. So you just add the two masses together to give you the total mass. Find out the weight by multiplying 10. That's how much force you have divided by the area that you calculated from the previous part. And boom, excellence is looking at you. All right, this one here. This is all right. So this is what I was talking about before, lifting. So if you're looking at lifting something up, remember we are dealing with the weight force. So they gave it to you. So this work that we're looking at here, work equals force times distance. You need to look at the weight force because you're lifting something up. You're overcoming is weight force. You need to figure out how heavy that is, which is given to you. Then you need to figure out how far I traveled, which is 30. So 60,000 times 30, done, achieved, 1 point that you just got for free. Calculate the power. Power equals work divided by time. So you need to use this number that you calculated here to go here, divided by 15. Boom, another achieved question, done. 2 achieved right now. You got 2 out of 8 already, 25% right here. Explain work. Explain what work is being done when it's hanging in the air without moving. Being done on the container when it's hanging in the air. So there's no work being done. Why is the work not being done? It's such a tricky question. The wording is horrible here. Explain what work is being done. No work is being done. Why is no work being done? Because the bloody thing is not moving. Because work equals force times distance. If your thing travels no distance, if there's no distance, whatever that is, times 0 is going to be 0. So no work is done. All right, so they give you a nice, beautiful force diagrams here. All right, so that's the last question, not yet. So refer to the diagram, explain the link between the vertical force. All right, so the container is being lowered. Okay, so look, they draw the diagram for you. So in this case, you need to understand net force. Net force is a combination of the forces acting on the object. So in this case, the downward force is weight. The upward force is the support from this, from the chains and from the crane. Okay, so the thing's being lowered, and that's because the weight force is greater than the support force being granted by the crane. Well, this is in a controlled manner. So as you can see, the arrow is larger. Then the downward arrow is larger than the upper arrow. That means this container will accelerate in the direction of the net force, which is downwards. All right, nice and easy. And this is the last question, I believe. The crane was lifting another calculate the energy the container had before the cable broke. Oh God. Okay, so this is a question. All right, so the crane was lifting and the cable broke. So you need to calculate the EP. You can see the number I just highlighted. You can calculate the EP. So 16. So remember, EP equals mgh. The mass is right here. This is mass. This is h. G equals 10. So straight away you can calculate EP. 16,500 times 10 times 15. That gives you EP. All right, and that means all of that EP will convert to EK. So you can calculate that, what that number is. Actually, why don't we calculate that? Why don't we calculate that? Why don't we calculate this? Okay, why don't we do this? So 16.5, oops, this is too small. So 6,500 times 10 times 15 equals 9750. So look at this number here. This is how many joules of energy it has. Oh, my wife just came home. Just gonna close the door. Just come home from work. Alright, so in this case, you can see that the the EP is 97500 joules. You can see the EK has 97000 joules just before you went. Where did the 5,000 joules go? Okay, where did the 5,000 joules go? So the 5,000 joules is lost because of heat and sound. Can you imagine the cable being broken when it's holding a crane? Like, that thing will start speeding right down. It's gonna rub against the chains or the cable. It's gonna make a sound, but one just as you can even hear it, just before even it lands, because 5,000 joules of energy is being lost through heat and sound and friction, so it's gone. Okay, so it's pretty easy. You can see it's like, once you get the hang of it, you just need to use the correct formula to do this question. All right, so Darlin asked a question, is there a usual question? Definition, yep. Mass, weight, pressure, yep. EPs, could be, not really, but pressure, not pressure, what's that called? Weight and mass, definitely, and pressure sometimes. And they will just go, what is pressure? So you need to understand pressure is the amount of force distributed over a certain amount of area. Okay, so just really quick, just a quick recap, like a summary. You need to know, because we've done this paper, speed run. If I were to sit this paper, this will take like 20 minutes because it's really short. So you need to, these equations are given to you. You need to know how to use them. You do not need to memorize them. You need to know how to use them. You need to know what units each of those letters have. So because when you use those equations, you need to go into the paragraphs and actually look for the unit, because numbers without a unit don't mean anything. So you need to find, like say in a paragraph, look at the numbers, look at the unit, and then what I normally tell my E11 students, just put the, like D, T, A, put the variable on top so you know what that number stands for. All right, and then if you do that frequently enough, and then you're gonna see, all right, I have this, I can figure out this particular formula, and that's most likely the right one. Okay, it's most likely the right one. And then the rearranging of the equation, that's just mathematics. I can't teach you math if most of you here are struggling here for science. I can't teach you math in 10 minutes. That just comes down to rearranging equations, making something the subject. But learn how those equations work. Just get into the habit, write down the equation before you solve the question. And then once you've done the question, you would have written down a numerical answer. If they ask you to calculate, please, for the love of God, write a unit behind the number. If you don't write down unit for physics, the highest grade that you can get for that question, if it's a calculation question, is achieved. Okay, if you do not, I'm going to emphasize again, if you do not write unit, or if you write the wrong unit, you will get achieved at best. You could have solved everything beautifully. No unit, no merit. Okay, no merit. It's as simple as that, because like I said, numbers without a unit don't mean anything. All right, and then like I said, you need to get another key thing. You need to get into the habit of looking at some of the answers you've done previously, and then use them again in the next following questions. Okay, you can. All right, now some questions here. this achievement standard is easy. Carolyn, I fully agree with you. It's the easiest external standard in level 1 science. But and then it gives people, a lot of students, false confidence that they think they can do physics, and when they go to level 2 and they get absolutely destroyed. Okay, because this level 1 is way too easy, and when they get to level 2, it's a completely different beast. And when we mark top down. So that means we look at excellence first. Okay, so if you got enough E's, we just give you E. We don't look at achievements and merits. Best way to study for formula, you just need to know what they stand for. I don't know, just do you know the units right now? And Grace is asking, do you know the units? So like say, for example, speed, meters per second, m is -1. D is time, distance, meters. T is time, seconds. Acceleration, m is -2, m is -1, seconds. Weight force, newtons. Mass is kgs, acceleration is meters per second. Per second, m is -2. Pressure is Pascal. Force is newtons, area is meters squared. EP is joules, mass is kg, g is just 10. Height is meters. I mean, most of it is just common sense, isn't it? Like mass is kg, speed, how many times we've done speed? Just meters per second. Force is always newtons, distance is always meters, work is joules, and power is watts, and joules, seconds, it's just the same thing, okay? You only write units at the end. Yes, you don't need units in the working. No, you don't need units in the working, but you must have units at the end. Okay? Must have units. In the mock exam, I got excellence for this question, but it seems easier than the question you're teaching right now. It seems harder to me. I don't know, Crypto Beast, but I can tell you that right now, guys. I've been doing this for quite a few years. I've been marking for quite a few years. I can tell you that the difficulty of the NCEA exams have been dramatically decreased. So it's getting progressively easier and easier. So if you look at this 2017 exam paper versus what the 2021 cohort would have done last year, the 2021 would have got it really, really easy. Okay, so, it's just it will get easier. So if you look at some of the harder questions in the previous years, that's probably why. Yeah, if you do level 2, don't feel scared about level 2 sciences. You put in the hours, you'll do well. Okay, you will, but you need to understand. You just need to be prepared that level 2 physics, chemistry, biology will be a lot harder than level 1. Okay, so this is why we have prerequisites. Especially at our school, I don't know, a lot of schools have prerequisites. So if you got, like say, if you get in level 1 sciences, if you got an achieved, like say for physics, don't do level 2 physics. If you can't get anything higher than achieve in level 1, you're just asking for trouble for picking level 2. Okay, I'm just gonna say it right now. It's not personal, because we want success for every student. I want all of you guys to do well. That's why I'm doing this right now. But sometimes you just have to understand that, maybe it's just not for you. Okay. Yep. How do you know what mark we can get for a certain question? So darling, so for the excellence questions, speed, time graph, distance under the graph, excellence. Pressure questions, comparing pressure, excellence. Assuming EP equals EK, energy conservation, the one that we kind of just did, excellence. That's about it. Work and power, excellence. Those are your guaranteed questions. Just print past 3 years exams. You find them all the same. Okay. What is the force? Force is a push or pull that will cause something to accelerate. There you go, mate. Oh, no problem, Stacy. You're in the wrong stream. Go away. You're year 12 chemistry students. Is it impossible to pass level 2 physics? It's not impossible. Heaps of people pass level 2 physics. What are you talking about, Marty? I'm just saying, if you struggle in level 1 science, don't do level 2 physics. It's as simple as that. Because you'll be lost after 2 weeks. It's, I've done this a lot, Crypto Bees. I've said this many times. And any year 12s will agree with me. Any year 13s will agree with me. It's not that I'm making this up. Year 9 is this hard. Year 10 is this hard. Year 11 is this hard. Year 12 is this hard. Year 13 is this hard. I've done this graph to all of my senior classes. So year 13 is the hardest, as you can see. It's the highest level. But if you look at the jump, it's not that big. Okay, so you just need to get ready. You just need to be mentally prepared for the jump. And if you're ready, you put in the work, you will do well. Science is a very fair subject because I was teaching science and did a lot of maths when I was at school and stuff. I like doing a subject that has a definitive answer. I would like to know when I work out the exam paper that I knew I put down the right answer or the wrong answer. For your literacy subject, you could have written what you thought is a beautiful English essay, then only to find out it's only good enough or achieved. So, need axes. I don't know what you mean by axes. You mean this axis? Oh man, that just made my week, man. If you talk about this axis, you are a natural physicist or mathematician. Need axes. Oh, it's so good. Oh, that's so good. Sorry, it's a bit nerdy for me to giggle there, but it's so good. You need axes. I can't agree with you more. That's so good. Yeah. Sweet. Sorry that it's just because my pen's not working. That's why I can't write as good as I normally could. Hopefully I can fix it and it'll work better next time. So the next stream that I'll do for you guys, level 1, will be, what's today? Friday. So Monday will be the last stream. Will be on genetics, and then that's us for this year. Okay. I already done chemistry, Mr. Crypto Beast or Mrs. Crypto Beast. Just look at the VODs. I already done that. Genetics is 3 days later on the Monday. Then I'm done with your cohort for the year. Okay. Oh, and by the way, I've said this numerous times. If you, I assume everyone uses Discord. So if you want to join the NCA level 1, 2, 3 science, just NCA level 1, 2, 3 Discord. If you're struggling in math, if you're struggling in English, if you're struggling in any other subject, there are tons of student helpers on there that do it for free. And I really respect, they're spending the time and going over stuff for you guys. And I'm on there every now and then and checking through things. So, yeah. Sweet. I think that's us for today. Almost an hour. Apologies for the late start. But physics, like you guys said, is the easiest one. So I hope you guys find some luck when you do this in a week or so of time. Okie dokie, that's us for today. I'll see you guys in a few days when we do genetics, and that will wrap us for the year. Alright guys, take care and have a good evening. See ya.